Hello again, Algebra 2 people. Today is going to be primarily a review of Algebra 1. Remember Algebra 1 days. I know with everything going on, it's been a while since you were in Algebra 1 classroom. You're kind of online for the last couple of months of the year last year. But this is really a review, just a review of that. It's never a bad thing to kind of go over some of those concepts. And then the Algebra 2 side of it is just a very pretty minor extension from what this is. So first of all, let me say this. If you don't have a printer or graph paper, you can do these same kind of graphs just on a plain piece of paper. And when I get to number 2, I'm actually going to just do this on a plain white piece of computer paper so you can kind of see how you can do it by hand, even if you don't have a grid or anything like that. So let's kind of get into this. So if you remember your old friend mx plus b, remember, your m is the number that's attached to the x, so my m in this case is -3, and my b is 4. And remember what that means. That's your slope and your y-intercept, right? And then also remember for inequalities, remember this symbol right here is a greater than or equal to. That little line underneath there says equal to, and whenever you see that line, we know it's going to be a solid line. And then also, if you think of it, it's kind of logical. If it's greater than, we're going to be shading this. Remember, inequalities have some shading on one side of the line. We're going to shade that above. So what's this line going to look like? So again, easiest way to graph these things is start with y-intercept. So at 4, and then we apply the slope. And remember, slope is always a fraction, even if it's not written as a fraction. So we go down 3 and right 1, or we can go up 3 and left 1. So down 3, right 1, and we can do that a couple different times. And then we can go backwards, up 3, left 1, and that way. And again, it's going to be a solid line. I'm going to do the best I can here. I'm not very good at drawing lines, but I'll see what I can do. And that's our line, right? And then when we go to shade, again, just think of, is it going to be above or below? And just physically, where does it look like? So if it's above, we're going to be shading all up in here. Okay? Now, if we're looking at the solution, remember, there's always an infinite number of solutions for any inequality, right? Because anywhere in this area is going to be a solution. But in this case, it's important to know that it's everything in shaded area, including, in this case, the line. And it's including the line because, again, it's greater than or equal to. Okay? So that's really it. So as we get into this, we're going to be graphing 2 or even 3 inequalities to see whether the shading areas overlap. But that's kind of the basics of it, of just kind of graphing an inequality. I'm going to do number 2, and again, I said a minute ago, I'm going to do number 2 just on a plain piece of paper, just so I can show you if I was graphing this and didn't have graph paper or didn't have a grid, how I would go about doing it. So this one is y is less than or equal to 3 over 5x minus 5, and just to show you that's the same equation. And again, doing the same thing, so my m is 3 over 5, and my b is -5. And if I'm doing this on a graph, I'm going to do an xy axis. And all I'm going to do is I'm going to do some lines, some little what I call tick marks, try to get them as evenly spaced as I can. Again, it doesn't have to be perfect, not using a ruler, just kind of eyeballing it and getting it as close as I can to be evenly spaced. I always say that I will never grade on artistic talent because Lord knows I don't have any. And again, do that on each axis. And I'm just calling each line 1. So I'm not even going to label that. You probably should, but I'm not too upset about labeling things. The only time you need to label is if you're calling each line something other than 1. If you like each line was 2 or something like that, then we'd want to label it. But if everything is 1, I think we're going to be okay here. Okay. And again, those are probably not all evenly spaced, but hey, this is going to be the best we can do. So again, we do the same thing. You go to b is -5, so 1, 2, 3, 4, 5. And then we do the slope up 3 over 5, and this is where kind of that estimation kind of comes in. So 1, 2, 3, and we go over 5. 1, 2, 3, 4, 5. So about right there. And we can do that again. So if I go up another 3, 1, 2, 3, 1, 2, 3, 4, 5. So about right here. And I can go backwards too. I'm just going to do those 3 points. And again, notice it's going to be a solid line again, and it's going to be shaded in below this time. So I'm just sketch a line in there as best I can, and then I'll grab a different color and just shade in all below that line. Again, is that perfect? No. Is it adequate and certainly acceptable if you kind of draw those lines in there? 100%. Okay, so even if you don't have a printer or don't have graph paper, you can still do these kind of things. And even when we get to the more complicated ones with 2 or 3 inequalities, you can still do it just on a normal piece of paper. Okay? So for the rest of them, I am going to use the graphs that I have since they are on there, and it makes it look a little bit prettier. But again, just know that you can do it on your own. Let's talk about a couple special cases that you had from algebra. If you remember, if you just have an x, think to yourself real quick, if it's just x and a number, what kind of line is that? And hopefully you said that's the vertical line. So we're going to do a vertical line at -2, so 2 over. And again, notice this is now going to be a dotted line or a dashed line. So at -2, do a dotted line. And also notice there is no above or below on a vertical line, but we can think of right and left. And again, since this is greater than, I'm going to shade in to the right of that line. And of course, if it was below, then I would go left. Okay. Now, just as a review from Algebra 1, if you think of a vertical line, remember the slope for a vertical line is actually undefined because it's like 1 over 0. So it is a good thing to remember that the slope of a vertical line is undefined. When we go to the number 4, again, if it's y in a number, that's a horizontal line. And again, in this case, the slope is 0. So again, we're going to go to 3, 1, 2, 3. Also a dash line or a dotted line. And in this case, and it's going to be below the line because again, it's less than. And again, remember on both of these, it's the whole shaded area, but not including the line. Okay, so if the line is solid, then the solution includes the line. If it's dotted or dashed, then the solution set does not include any points on the line itself. Okay, so now instead of graphing just one inequality, let's graph 2 of them. And in fact, on your assignment that we'll look at, you're actually going to have 3 equations to graph and figure out where the shading area is overlapping. Okay, so let's take a look at this guy here. So again, my first equation, I've all set up for us. So we got 1/2 and 2 for the y-intercept. We know this is going to be a solid line since it's an equal sign, and we know it's going to be below since it is less than. So I'm going to go and graph that line. So we got 2 and the slope of 1/2. So up 1 over 2, up 1 over 2, up 1 over 2. And I can go backwards. And again, I'm going to make that a solid line as best I can. Now, I'm not going to shade it in just yet. I'm actually going to do the shading at the end. because I want you guys to see, because really all we care about for the answer is where it's overlapping. Okay, and I'll explain that in just 1 second. So bottom equation, I'm going to do this one in red just to kind of offset a little bit. So again, we have our slope of -2, y-intercept of -3. This is going to be a dotted line or dashed line, and we're also shading that in below as well. So I'm going to graph that line. So 1, 2, 3, and then a slope of -2. So we're going to go down 2 over 1, down 2 over 1, and go backwards. And notice this is that same point there. That's good enough. And there's that line. Okay. Now, here's what I want to do. I'm going to divide this into, like, if you see there's kind of 4 sections here. There's a section here, there's a section here, a section here, and then a section over here. Okay. What I want you to do, just for a couple seconds, and if you need to pause the video, you can, think about, knowing we're going to shade in below both of those lines, which section will that overlapping area be? And I think you see that if we're below the black and below the red, we're in section 3. So that's the only place that I'm going to overlap in. Now, if you're doing this in pencil, there's certainly a way that you can kind of shade in lightly on both of them, and then where they're overlapping, shade in just darker, and that's completely okay. But I like just kind of figuring out the overlap and just filling in that one, so it's nice and visible of what we're talking about. Now, before I go on to the next example, let's talk real quick about solutions. Okay, and I'm going to pick a couple points, and you think, is it a solution or not? So the first point I'm going to use is 0, 0. So look at the graph here. Is the origin part of the solution set? And if you look right here at this point right here, it's not in the shaded area, so that's a big no. Okay. How about the point? How about the point -3, -1? So we go -3, 1, 2, 3, -1, definitely in the shaded area, so that's a yes. How about the point 1, -5? So we got 1, 2, 3, 4, 5. Is that point a solution? That's actually a no, because notice that point is on a dotted line, so that is not a solution. And then how about the point, how about the point, how about the point -4, 0? That is a solution, because again, it's on that line, but that's a solid line. And then in class, I had one more question. They said, what about the intersection point? Well, that point there, and that is -2, 1, that's actually a no, because it has to work on both of them. And because that dotted line is there, the dotted line kind of overtakes the solid line. Okay? And of course, anything down here is going to be a solution also. Okay? So I got a couple more examples to do, and then we'll kind of wrap it up. So if you want to pause the video and see if you can do these last 2 examples. Now, these last 2 do involve a little bit of algebra, so we got to get y by itself first, and we'll kind of go from there. So on this example here, remember, we want to get y by itself, so just do your algebra. So we got 2y is less than -3x plus 4. Divide everything by 2, and we have y is less than -3 over 2x plus 2. Do the same thing on this guy. 2y less than or equal to x plus 4. Divide everything by 2. And we have y less than or equal to 1/2 x. Remember, x over 2, same thing as 1/2 x plus 2. Then we'll do our lines. So we have the slope of -3 over 2. Y-intercept of 2. It's dashed and below. And this guy is going to be the slope of 1/2. y-intercept of positive 2, solid, and also below. Okay, so let's go and do those. So we have the y-intercept of 2, negative 3 over 2. 1, 2, 3 over 2. And I'm just going to do a couple of lines just for the sake of time. 1, 2, 3, 1, 2. We know it's going to be a dotted line. And then my second one starts at the same place at 2, but now the slope is positive 1/2. 1 over 2, 1 over 2, 1 over 2. And that's going to be a solid line. And again, think in terms of sections. So if this is 1, 2, 3, and 4, I want below on both of them. So below and below, my overlapping area is going to be all in here. And again, any point on a solid line works. Any point on a dotted line will not be a solution. Last one. Number 7. And again, we do the same thing, right? So 5x minus 3y less than or equal to negative 9. But there is an extra thing you got to remember on this. So we're still going to get y by itself. So negative 3y less than or equal to negative 5x minus 9. When we divide by negative, what happens? Well, we know the inequality switches. So it's y is greater than or equal to 5 over 3x plus 3. Watch your signs. And then same thing on the other one. Negative x minus 3y is then equal to 3. Negative 3y less than or equal to x plus 3 divided by negative 3. So we have y is greater than or equal to negative 1/3 x minus 1. Okay? Don't forget to change the inequality if anytime you divide by a negative. So we got 5/3 and 3. That's a solid and above. And here we have negative 1/3 and negative 1 and solid and above. So here we go. We got 3 and up 5 over 3. 1, 2, 3. Whoops, too far. 1, 2, 3, 4, 5. 1, 2, 3. It's got enough there. So a solid line. I'll just use those 2 points and sketch it in there. And then negative 1 and negative 1/3. So down 1, 1, 2, 3. And also a solid line. And again, think in terms of sections. So if that's 1, 2, 3, 4, I want above on both of them, above and above. That's going to be here in section 1. Okay? And that's pretty much it. And remember, on this one here, any solution in the shaded area and on both lines this time, those are all going to be solutions to that system. We can do this algebraically just real fast. So you can check the point, if you're just given the equations without even graphing them, if the question is it a solution, you can just plug in. But it has to work for all three, or however many inequalities you have. It's got to work for all of those. So if I plug in the x and the y, so this would be 2 times 5 plus negative 4. Is that less than 9? That's the question. So we just work it out, right? So we got 10 minus 4 is 6. 6 is less than 9. That works on that one. So we got one of them done. Check the second equation. So it says negative 4 is y. So is negative 4 greater than negative 8? Yep, that works too. How about the third equation? Again, plug in negative 4 greater than or equal to 3 times 5 minus 20. And that becomes negative 4 greater than or equal to, that's 15 minus 20 is negative 5. Is negative 4 greater than negative 5? Yes. So that is a solution. Okay. We can do the same thing if we go to the second point, 8, negative 7. Well, if I plug that in, I have 2 times 8 plus negative 7 is less than 9. We check that. 16 minus 7 is 9. 9 is less than 9. That is already not correct because there's no equal sign under there, so that's not right. So automatically, 8, negative 7, not a solution. If it had worked for the top equation, then we check the second equation, check the third equation. Remember, it has to work for all three in order to be a solution. Okay, so that's a review of some Algebra 1 stuff and getting into kind of what the Algebra 2 side of that looks like in inequality systems. Feel free to come to tutoring, ask any questions. Until next time, stay safe.